Thanks a lot, Morten. It's very nice to be back here. Infrastructure is exactly the same, but the organization surrounding it is extremely different. Carbon capture and storage is one of the cornerstones of the Norwegian government's climate initiative. And the good thing is that there is a fairly broad political agreement across the parties that this is one of the key activities from Norway's point of view, combating the climate change. Carbon capture and storage as such, there's been some discussions about the usefulness and the importance. I think nowadays, and especially after Paris, the general opinion is that it is one of the key tools in the toolbox in order to reach the Paris goals. And indeed, if you want to move below the 2 degrees down to 1.5, it's actually a complete necessity. It's also important to realize that when it comes to the energy sector, the growth of the, let's say, renewables is tremendous, and it's extremely important that this accelerates. But even so, the major part of the energy production will be fossil also for many years to come. Another issue which is extremely important to realize is that for some of the sectors, like the industrial sectors, like the steel, the aluminum, and the cement, it's actually the only solution. Norway has decided to do a very focused effort on carbon capture and storage, and it can basically be divided into 3 main pillars. You have the Climate Research Fund, which is basically a fund of money which is going to research into carbon capture and storage. We have the activities at Mongstad, which is number 2. And of course, the most important, it's the ongoing process of developing a full-scale carbon capture infrastructure in the North Sea based on capturing CO2 from various industrial sources in Norway. And I will give you a small insight into each of these and elaborate a little bit more on the technology center Mongstad, since that is basically the organization I represent. The climate funds has been operational since 2008. They have supported more than 300 projects, and the current annual budget is around 223 million euros, which is roughly a little bit more than 200 millions. The focus areas now in the new program plan is to make sure that we manage to develop an early full-scale CCS solution in Europe, supporting the large-scale storage of CO2 in the Norwegian shelf, and of course support cost-effective technological solutions for CCS. It's also an aspect of this that the funds should be done in such a way that they also support international cooperation. I will mention 2 examples of, I will say, random projects. The Solvit, which is one of maybe the biggest individual one, is basically about developing novel solutions for capture of CO2. It's done in close cooperation with industry, and I have to say, has actually developed amine technology into a new level. And compared to the baseline now, some of these solvents have a reduced energy consumption of up to 35%, and also cost reduction of 35%, which is a very good contribution. A second example, this is May-Britt Teg from NTNU. Together with her colleagues at NTNU, she has developed a completely new type of polymer-based membranes for CO2 separation. This has been tested at SINTEF. It's also been tested at Norcem, and they have now entered into a joint venture with Air Products, which is basically developing this into commercial models. We are now in dialogue with NTNU and also Air Products to see how we can facilitate the first large-scale testing of these technologies. This is only two examples of 300 different projects enhancing the technology for capturing CO2. Now into basically my favorite topic today, that's of course the technology center at Mongstad. This technology center has basically now developed into arena not only for testing, but it's also an arena for training, problem solving, and actually supporting development of capture technology. We obviously provide an arena where companies and scientific institutions can test their technologies into, let's say, industrial scale. But we also see that we are basically now gradually developing into a global competence center for capture technology. The center has been in operation since 2012, and we now have a new operational agreement with the owners, and as of this year we actually have 3 industrial partners: Total of France, Statoil, which you know, and Shell, and they are now 3 equal industrial partners in addition to Gassnova, which holds the state interest. And it's I would say a very good development of the center, and it actually gives us an opportunity to really focus on the future. If you look at the activities at the technology center, it can be basically divided into 3 different parts. We do the test campaigns with the technology vendors. This is of course a very proprietary development, a lot of secrecy, a lot of, let's say, information that cannot be shared. But we also now do more and more what we call open scientific campaigns, where this is non-proprietary competence, and what we see is that the interest for these kinds of campaigns is actually increasing a lot, and the importance of these campaigns is actually as important now as the proprietary campaigns. I will go a little bit more into the details later. Based on this, and based on 5 years of operation, we are also now seeing an increased interest in our role as a global competence center for capture technology all over the world. So what can we offer to a vendor? Basically, large-scale testing of real industrial flue gas, scientific support, emission control, support on approval process, analytical methods, and of course operator training. And I have to say that the interest for doing this is increasing, and as mentioned earlier by DNV, we also definitely see that there was a turning point after the Paris Agreement. Something happened, and it basically increased the attention a lot also on our activities. So far, 5 companies have been testing the technology, and some of these has been back actually 2 times, and we have now. I'm not saying that the queue is long, but it is a queue, and we see that occupation until 2020 will not be an issue. I would like to share with you a small video which our latest customer has shared, and that is basically Ion Engineering, which is the first true-born child of the Norway-US bilateral cooperation on carbon capture.
My name is Buzz Brown. I'm the CEO of Ion Engineering, a company in Boulder, Colorado, focused on removing carbon dioxide from industrial emissions. The center is operated exceptionally well at all levels. I mean, not just the design of experiments or the analysis of results, but at all aspects, the safety, just the overall operations of the plant. The expertise here is really, it's really superb. They're not only experts in their field, but they're experts in the development of technologies like ours. The TCM engineers and operators are truly interested in the science and how the solvent works and how to operate optimally our solvent in their facility. That gives us great flexibility. The main advantage is that there is no facility like this anywhere else in the world. And it's everything from, like I said, the pilot plant itself, instrumentation, the analytics, the engineers, and really the collaborative relationship we have with the engineers, with the operators, and with the staff here. So the costs here are definitely comparable to other facilities. We receive significant funding from the Department of Energy and support from TCM and Gasanova to test here. So, as I said, it's really comparable to other facilities, which again is a huge advantage for us because we're not having to bear the expense of building such a facility. Arriving here is a huge milestone for us, hopefully the last step before commercialization, and it really is a significant milestone for this company. To get here, we really have to be one of the leaders in the industry, and we take great pride in the work we've done and accomplishments to get here.
Okay, he was not paid to say this, so it was entirely voluntarily. The second kind of campaign, as mentioned, is what we call now the open scientific campaigns. And I think the reasoning behind it is very simple, that if you look at the typical upscaling of any technology, it's a very, very scientific route. And what we see is that there is an increased interest in actually also the non-proprietary part of developing these technologies. And therefore, we are focusing much more now on the cooperation both with universities and research organizations. And we have just recently signed a cooperation agreement with SINTEF, and we see that these kinds of combinations is actually increasingly important also for accelerating the capture technologies. To illustrate this, I will only show you one slide illustrating the scientific campaigns we actually just started last week. It will actually go until November, and if we see it, it's actually it's like a Kinder egg. You actually bundle a lot of things together into one campaign, and as you see, there is a big amount of sponsors, a very broad collaborations. And that actually includes both academia, industry, and research organizations. We also see that we bundle everything together. It's fair to say that it's a fairly expensive exercise to do these kinds of experiments. So you need to be sure that you get as much, let's say, competence into one campaign. And as we see here, this campaign is actually divided into 5. One part, which is basically much decided by the owners, Statoil, Shell, and Total, is very much about cost, reducing cost of the process. Then we have a very interesting process together with a Norwegian technology company called Cybernetica, which is more about adaptive process control of these, which at the end of the day will also have a cost impact. We have a major campaign here on exploring the mechanisms of emissions, which is still one of the key issues to solve. We have some issues on material technology, and we actually bundle everything together, and some of these universities have actually also got sometimes to develop both master degrees and PhDs. So we see there's an increased interest for this, and we also know that in 2019 we will have a major EU campaign called ACT, where we basically do more of this kind of open source technology, and it is increasingly seen as one of the key issues to decrease the cost of capture. On the competence side, as I said, after 5 years of operation, we have developed, I would say, this TCM into a global competence center. And some examples, as mentioned, we have a bilateral US-Norway agreement. It's fair to say that after January, it's been a lot of, I would say, a little bit anxiety on how basically this will develop. What we see is that kind of interesting is that one part use of carbon capture is for enhanced oil recovery, and of course making USA great again and actually more energy self-sufficient has actually initiated that they are looking for more kinds of capture technology for this purpose. So we believe that this will continue. We are actually one of the leaders in what we call the International Test Center Network. We are signing more and more collaborations agreements both with academia and research organizations. And we actually now make more and more agreement within a national CCS project. And we actually came home from China last week, and we have signed actually 2 agreements with a Chinese CCS project. And there our role is more as a, it's not a consultancy, definitely not, but it's about competence sharing, and the interest is basically growing. We also see that we get more and more dedicated spaces at the conferences for the congregation, and GASGT, which is the big greenhouse gas technology conference, we had actually a separate technical session dedicated only for us. So the interest for what we are doing is increasing, and it's very nice as a small, humble Norwegian to work around with this in the world, because on this particular, I would say, little aspects of climate activity, Norway is actually in the front. Which basically leads me to my last part, and that is the full-scale project. As probably most of you know, Norway is now intending to develop Europe's first full-scale application of carbon capture and storage. 3 areas, all industrial, non-energy, has been selected. It's the Norner plant here in Grenland, it's the Yara, which also is here, and it's the Klemetsrud waste-to-energy plant. The transportation part is basically being done by ship, and there is a formation in the North Sea called Smeaheia, which is basically being prepared for the storage part. The timeline for this is that the concept selection has already been done, and this is not, it doesn't really work, so I have to explain here. The concept selection, both for capture and for storage and for transportation, is done. We will now, during the fall, select the concept and move into the feed for the transportation and for the capture. Thank you. And then a little bit later, we will also move into the feed and the concept selection of the storage. Actually, I believe the storage operator will be chosen any day now. And then the final investment decision for this will be taken sometimes late 2019, and the way it looks now, it will be operational full-scale 2022. The interesting part of this is not only that Norway leads the way in Europe on carbon capture and storage, but it's also an interesting aspect that the capacity here, I mean, the total Norwegian CO2 outlet will maybe occupy like 0.1% of the capacity, meaning that this is an excellent infrastructure for carbon capture, at least for this part of the world, and especially for German process industry, where the storage aspect in Germany has been a highly sensitive issue. This is very interesting. So this is actually creating the first European infrastructure for storage with a flexible transportation system is really, really interesting. So in a way, the time is now actually for doing it, and it's very, I would say, rewarding and interesting to see that Norway is actually in Europe leading this activity and creating the first full-scale infrastructure for capture and storage in Europe. Thank you.